Okay, let's get started. Today we're talking about functions. And what do we mean by functions? Well, we've got a nice little video that we'd like to show you that talks about functions in a meat processing plant, a place where you bring in certain products and you produce food. But when it gets right down to it, in mathematics, functions go this way. Well, we need to start with talking about what a relation is first. A relation, not relationship, but a relation is any set of ordered pairs which amounts to a set of input and output values. We've been talking about these XY values and we've been plotting them on graphs and that type of thing, but we want to start thinking of them as inputs and outputs because they are generated by mathematical relationships. A function itself is a special relation where each input has exactly one output, which basically means that if I put a number into an equation, it will do some operations on that number and then put out an answer or output an answer. And if I put the same number back into the same equation, I better get the same number out. If I get a different one, then something is not working and it's not considered a function. Okay, a couple of other vocabulary words that go along with this is the domain. The domain is the set of all the possible input values or x values that could be used in an equation to get some output values. And the range is a set of all the possible output values or y values. And it just depends on what function that you have, what kind of domain and range you can expect. A couple of other words that go along with these very same values is the independent variable is the variable that represents the input values or the x values, and the dependent variable is the variable that represents the output or the y values. And this is super important to remember that because there will be some questions you'll see in some of your assignments where it will say, what is the independent variable? Well, you'll have to look for what the x values are, or what is the dependent variable. You'll have to look at what the y values are. For example, here, Manuel works at a water park. He notices that the daily high temperature affects the daily number of tickets sold at the park. And here's the graph below that shows that. Well, the independent variable would be the daily high temperature, or the dependent variable would be the daily number of high tickets, or not the daily number of tickets sold. And it kind of makes sense that the warmer it is, the more tickets they're going to sell because more people want to go to the water park to cool off. Here's another one. The table below shows how the monthly payment of a life insurance policy depends on the age of the person. So you notice as the person gets older and closer to death, if you think about it, the amount that they charge you for their life insurance also goes up. So age is independent variable. The dependent variable is how much they're going to charge you. Okay, so kind of review then. So we've got a couple of things to look at here. We know that the x values, I'm going to write that up there. Well, x values is also considered the input, the domain, and the independent variable. Meanwhile, the output consists of the y values. It's also called the range, the set of all the y values, and it's also called the dependent variable. And a function is a relationship that pairs each input with exactly one output. Each x value is paired with exactly one y value. So it's always important to remember you're going to look at the x values and see, do they each have their own one y value, or are they paired up with more than one y value? So here's a couple of ways to check that. If you look at this, we've got the inputs over on the left side, the x values, and the y values on the right side. Well, 3 only has an output value of 0, the input value of 6, 4, 9, 0, 12, -4. See how each of these inputs only has one output? Even if the output is the same number, it's okay. It's just that each input can only have one of its own outputs. So in this case, this would be, yes, it's a function. On this particular one, the input shows up, number 2 shows up twice in this list. And the output that goes with that input on the first case is 2, in the second case is 1. So something's not working in this particular situation. So this is not a function. Maybe you can look at it by saying it's not working, so it's not functioning properly. Sometimes they put these x and y values in a little set of mapping diagrams like this, and so you can say, oh, if I have an input value of 4 and it has 2 different outputs, that's a sure sign that this is not a function, because each input can only have one distinct output. Okay, each of these inputs only have one arrow leaving them, so that's a good sign. Even if 3 and 5 go over here and they both result in an output of 4, that's okay. So in this particular case, each input only has its own output, so that is yes, it is a function. Okay, a couple more. So there's a relation. You got the door goes to -7, sky goes to -9, moon and desk each have an output of 4, so that is considered to be a function. Relation number 3, we're going to focus on the first letters, A, N, U, D. All of those are different. And because they're all different, that means that no matter what their outputs are, they only have one output in their case. So this would be a function. Now this may sound a little tricky, a little confusing, but just with a little practice, you'll get really good at it. Okay, another way to tell if a function is a function or a graph is a function is what we call the line tool, the vertical line test. And that basically means that a vertical line, if you draw several of them through the whole graph, in order for this graph to be a function, every vertical line can only cross the graph once. So what does that look like? Well, here's a bunch of different crazy looking graphs. If I start drawing vertical lines though, in this particular graph, I actually hit 2 points. And I also hit 2 points here. I can't do that if it's a function, so this is not a function. On this graph, even though it's not a straight line, it's a corner, if you will, any vertical line that I draw will only hit the line once. So it is considered to be a function. Same thing here. These points are not lined up vertically like these were. You only hit 1 point at any one time, so yes, this is a function. Over here, we've got a vertical line here that'll hit twice. There might be a few places where it only hits once, but there's a section right through here where it hits twice. So that means that this is not a function. A vertical line over in this section will also hit twice. Over here, a vertical line wouldn't hit at all, but all it has to do is fail the test in any one spot and it would be considered not to be a function. And this last one, of course, any vertical line through here would hit that baseball diamond shaped figure twice. So this would not be a function. So the vertical line test is actually a pretty way to tell if something is a function. Okay, sometimes a function is defined in this way. We have instead of putting y there, we've got some function h that looks like this. It consists of this equation, 4x plus 5. So if we want to find out what the outputs are for these 4 inputs, basically we just kind of set it up with this information up here, and we put the numbers in. So -3, -2, 0, 1, and 3. So we put the inputs in for x, and then we determine the outputs. 4 times -3 is -12. -12 plus 5 is -7. 4 times -3 is -12. Oh, I put that in. That should be a -2, huh? 4 times -2 is -8. -8 plus 5 is -3. 4 times 0 is 0. 0 plus 5 is 5. 4 times 1 is 4. 4 plus 5 is 9. 4 times 3 is 12. 12 plus 5 is 17. So there you go. You've got a set of inputs, a set of outputs, and so these numbers you would just write in these boxes or type them in these boxes if it asks you this question in ALEKS. Okay, here's a couple of word problems where we've actually got some a function. In this case, this function represents cost. So an amusement park charges an admission fee of $30 per person. The cost C in dollars of admission for a group of P people is given by the following function. So what would be the cost if 4 people went? So in this cost function, if you will, we're going to find out what the cost would be for 4 people to go. So that would just be 30 times 4, and 30 times 4 is $120, right? So pretty straightforward. And so these functions can be used to find out all kinds of things. In fact, if you knew where they're used in your daily life, they're used to find the cost of your food, the taxes on your food, all kinds of things when you go shopping. So here's another one. Salma rented a truck for one day. There was a base fee of $12 and there was an additional charge of 25 cents. That should be an S right there. 25 cents for each mile driven. The total cost, C in dollars, for driving X miles is given by the following function. So if he drove 20 miles, what is the total rental cost? So we're going to put $20 into the function, or 20 miles into the function to find out what the total cost is. So when we do that, we end up with $12. Oops, I gotta get my decimals right. $12 plus 0.25 times 20, or 25% of 20, which is 5. So that would equal a total cost of $17. So the total rental fee for driving 20 miles, $17. There's one more here that I don't believe is on our notes, but this is the kind of problem you might see in the ALEKS. And could be a little bit of a surprise kind of problem. So let's look at it. A railroad crew can lay 7 miles of track each day. They need to lay 289 miles of track. The length L in miles that is left to lay after D days is given by the following function. So here's the total amount they have to lay to finish. And this is how much less they have each day because they're laying 7 miles a day. So how many days will it take the crew to lay all the track? So what we do in that case is we just say how much will it take until the left side equals 0. And that means they would have no track left, right? So we move the 289 to the other side and we get negative 289 equals negative 7D. And then if you calculate that on your calculator, and I'm going to calculate that on my calculator that you won't see, but you could try it with your calculator. So 289 divided by 7 comes out to be, excuse me, 41. So it can be about 41 days if I divided that correctly, okay? Well, how many miles of track does the crew have left after 18 days? So in that case, we're going to put 18 into our function, So in that case, we're going to put 18 into our function and multiply by 7, and then subtract that number from 289. So when I get my calculator, and if I do 7 times 18, I get 126. So then I go 289 minus 126. I end up with 163 miles. So that would be our final number. That's how much they still have to lay after 18 days of work. So our assignment is number 39, Introduction to Functions on ALEKS. Grab a box paper and get to work. This looks pretty fun, doesn't it?